Children, next, what is meant by EMF? Already we have learned two half cells in Daniel cell. One is oxidation half cell and the other one is reduction half cell. So here in the Daniel cell, a spontaneous redox reaction takes place in which the flow of current from anode to cathode, current from anode to cathode. So the force that pushes the electrons away from the anode and pulls towards the cathode is called electromotive force, that is EMF. So what is EMF? The force that pushes the electrons away from the anode and pulls them towards the cathode is called the electromotive force, EMF, or cell potential. The SI unit of cell potential is volt. When there is 1 volt difference in electrical potential between the anode and the cathode, 1 joule of energy released for each coulomb of charge that moves between them. So 1 joule is equal to 1 coulomb into 1 volt. 1 volt. The cell voltage depends on the nature of the electrode, concentration of the electrolyte, and the temperature at which the cell is operated. For example, at 25 degrees Celsius, the EMF of the Daniel cell, the below mentioned zinc ion, salt bridge, this is phase boundary, this is salt bridge, zinc in zinc sulfate, copper in copper sulfate. The E0 value, standard E0 value is 1.107 volt. So the cell voltage depends on the nature of the electrode, concentration of the electrolytes, and temperature at which the cell is operated. So the overall redox reaction can be considered as the sum of the two half reaction. One is oxidation half reaction, the other one is reduction half reaction. Similarly, the EMF of a cell can be considered as the sum of the electrode potentials at the cathode as well as anode. So E cell is equal to E, that is oxidation at anode, plus E reduction at cathode. E ox anode, this represents oxidation potential at anode, this represents reduction potential at cathode. It is impossible to measure EMF of a single electrode, but we can measure the potential difference between the two electrodes using a voltmeter. If we know the EMF of any one electrode which constitute the cell, the EMF of the other electrode can be measured. So for that we need a device, that is we need a reference electrode whose EMF is known, that is called standard hydrogen electrode, SHE. Standard hydrogen electrode consists of a platinum electrode. It is used as a reference electrode having 0 volt. It consists of a platinum electrode, contact with 1m HCl or sulfuric acid, and hydrogen gas is bubbled inside at 25 degrees Celsius. So she can act as well as the cathode as well as the anode. The type of electrode is gas electrode. The components platinum electrode, hydrogen gas, electrolyte component sulfuric acid at 1m. Then electrode representation is platinum, hydrogen gas, 1 atmospheric pressure. This is the electrode representation. So hydrogen electrode consists of a platinum foil connected to a platinum wire sealed in a glass tube. The electrode is in contact with 1m H2SO4 and hydrogen gas is constantly bubbled. So what happens? She can act both as cathode as well as anode. At cathode, reduction happens, anode oxidation happens. So in the cathode, 2H plus 2 electrons forming H2. E naught value is 0 volt. At anode, oxidation takes place. H2 giving 2H plus 2 electron. Here also E naught value is 0 volts. So what is electrode potential? Means electrode potential E, in which the electrode on the left is a standard hydrogen electrode and the electrode on the right is the electrode in question. So the value of the standard EMF of a cell in which the molecular hydrogen under standard pressure is oxidized to solvated protons at the left hand electrode. So based upon this, a series is framed that is called electrochemical series, that is single electrode potentials measured using standard hydrogen electrode at 298 Kelvin. It is given in a book page number 62. That is called electrochemical series. This is called electrochemical series. The values are arranged in the decreasing order of their standard electrode potential. So this is the standard reduction potential E naught is a measure of oxidizing tendency of the species. The greater the E naught value, greater is the tendency by the species. That is, if the value is greater, E naught value if it is greater, greater is the tendency of the species to accept electrons and undergo reduction. So higher the value of E naught, lesser is the tendency to undergo corrosion. For that only the rules are given here. So if you should know, if the value is higher, less the value of the EMF value 290, if it is higher, lesser is the tendency to undergo corrosion. That's a very important sentence. Higher is the value, E naught value, lesser is the tendency for the metals to undergo corrosion. She means standard hydrogen electrode. It is given book page number 48. And the EMF, what is meant by EMF? It is given here, the force that pushes the electrons away from the anode and pulls them towards cathode is called as electromotive force or cell potential.